Well, hello and welcome to Chapter 6. This is called Polynomials and Polynomial Functions. We're going to start with Section 1, and it's called Operations with Monomials. That's right here on this title. And basically, guys, we're going to see if we can apply this large list of properties of exponents, but I think you'll see how they overlap in some cases. Secondly, there's going to be different situations when we add, subtract, multiply, or divide, and we'll do dividing in the next section. And we're going to use these properties that we learned from our first bullet point. And then finally, are we able to identify the degree for a monomial or a polynomial? And degree is dealing with the exponents of that actual monomial or polynomial. So let's get to it, and we'll get on to some examples and some different topics throughout this lesson. Okay, everybody, what I might encourage you to do is listen to me the first round through this list of properties, but then I would encourage you to jot down all of these properties in your notes so that you have these available. We're going to start off with the product of powers. The product of powers says that we have two things being multiplied, and we have to have the same base. In this case, the letter x is the base. So when we have the same base and we're multiplying powers, we can actually just add the two exponents, a and b. And you see that illustrated over here. 2 plus 4 is the 6. And 2 and 9 is 11. But we have to have the same base. This would not be possible if it were 3 squared times 2 to the 4th. Or p squared times x to the 9th. Not possible. But since they are the same, we can do it. So when we multiply powers, we add the exponents. When we divide powers right here on the quotient, we subtract the exponents. Again, got to have the same base. X and x, 9 and 9 right here. 5 minus 2 is 3. And 6 minus 4 is 2. Now, when we have variables, we have to stop there. But 9 to the third power, you could actually do 9 times 9 times 9 and get your answer. I think, well, I don't know, 727 or something like that. Anyways, negative exponents, the third one. If you have anything with a negative exponent, what that is telling you to do is to flip it down to the denominator. So in this case, since it's over 1, the 1 goes up top, and then the x to the a becomes positive, and it looks like a fraction like this. So we basically just flip this upside down and make the exponent a positive one. Well, what happens if you start off with a negative exponent in the bottom part of your fraction? You flip the bottom part up to the top, and you end up with just x to the a. The 1 is technically on the bottom, but it was just over 1, and we know that to be just the same thing. Here's how it works. Over here on the right, 3 to the negative 5, it will turn into be 1 over 3 to the 5. And then on the bottom, you have 1 over b to the negative 7. So you flip the b to the negative 7 to the top, and we don't have to write the over 1 part because that's understood. Alright, we're going to see some of those in a minute. This is a power of a power. So we have a power, x to the a, and it's raised to another exponent, b. So when you have a power of a power, you're going to take the exponents, a times b, and multiply them together and have the same base of x. So if it's 3 to the third power squared, it's really 3 to the 3 times 2, or 6th. And then same thing, d to the 8th for that one. Now what's a little different is this one. The power of a product. X times y is a product. We're going to take the power of that. So basically we can distribute the exponent to each piece on the inside of the parentheses. So it's x to the a and y to the a. So over here you have 2 to the 4th and k to the 4th. Well, 2 to the 4th is 16, and k to the 4th is just k to the 4th. And you see how it works with just variables as well. You just distribute the third degree to each variable, each base. Second to last, the power of a quotient. Very similar to the power of a product. We're dividing x over y. We have an a as our exponent, so just apply the a to the top and apply it to the bottom. X to the a, y to the a. If it's a negative exponent outside of the quotient, go ahead and flip the x and y upside down. So now you have y and x, just like we did earlier, but now the a is positive, and so we say y to the a over x to the a. And here's it with some numbers. X squared over y squared, that's pretty simple. A over b is to the negative exponent, so we have to flip it. So it's b over a to the positive 5, and you see the result. Okay. Last one, the simplest one, is the 0 power. Anytime you raise a base to the 0 exponent, it will always be 1. Understand that. 7 to the 0 power right here, right here is 1. If I gave you all of this in parentheses, x squared plus 14x pi plus the square root of 2, and I closed the parentheses, and on the outside of that I raised it to the exponent of 0, that's still just going to equal 1. Alright, pause this, write some of these down. Okay, before we get too heavy into simplifying some problems, let's understand what it means to be fully simplified. So basically, guys, the first one, you cannot have any more powers. We don't want to have any more exponents on top of a number. We want to simplify everything. Secondly, each base appears only once, so we don't want to have say x squared times a 3x squared. Actually, let's make that a plus. So, that's going to be 4x squared. We don't want to have that, so we would have 4x squared. All right, sorry about the 2. All fractions are in simplest form. The third one, we don't want to have something like 4 over 2. We want to have 2. So make sure you simplify your fractions. And also you want to cancel out any variables that you could possibly. And in the end, there are no negative exponents. So if you finish off your problem and it has something like x to the negative 2, please make sure you switch that over to 1 over x squared. Just like in our properties a second ago. Alright, here come some problems.